Get started with section 4.5. All right, remember everything's due on August 10th. We'll have no live meets during the final tonight. So you guys have already done your surveys. I will drop the lowest for homework grades. So if you get to the decision where you're like, ooh, I need to take a test, or ooh, I need to do homework, you should take your test if you feel like you're not going to have enough time to do everything, because I do drop your lowest homework grades, including zeros. Also, test 2 is due tonight. You had a whole week to take test 2. Test 3 opens tonight, or it may have opened a little bit earlier. And there is a review video, of course, for test 3. And then your final exam opens on August 9th, which is Tuesday. You have to complete it by August 10th. They don't let us keep that open for like a week. That's not allowed. So that's why I try to do best I can. At least I'm giving you like 2 full days. You've got to pick a time in there to take that final exam. And the final exam review has videos that the other instructors and professors have already made to go with each problem that show you how to do it, which is kind of a nice thing. But like I said, if it's something that we did not get to, you don't have to worry about that counting against you. I would never do that to you. Okay, let me X out of my email. I always keep it open because I'm afraid like people are they're emailing me because they're like running late to class. Okay, so we are gonna do a little warm up today. This is what we learned yesterday, and this is part of your objectives, is being able to write from log to exponent and from exponent to log. And so I know that we had a few people that weren't able to make it last night from extenuating circumstances. So I want to show you, I'm going to do one from each. So I'm going to do one of these. So this would be 13 squared is equal to 169. And so that's how I write it as an equivalent exponential expression. And then down here, I'll do one of these. This would be the log of 2 base 4 is equal to 1/2. And that would just be my answer. We're just rewriting these. This is a question on your test, this type of question. So I'll give you a moment to try it. If you want to type it into the chat, you can. I know it's kind of difficult to type into the chat sometimes, but you guys are pretty clever. You guys have found ways to do that. So I'll give you a few minutes and then we'll get started with 4.5. All right, I'm going to go ahead and start writing my answers to make sure we're all on the same page. So for number 2, I would start with 121. I can go across, so it would be 121 to the negative 1/2 is equal to 1/11. So I always start with a little number. That's my base. So on number 3, 4 is my base. I go across the equal sign. That's my exponent. And then it equals the number here. And yesterday we learned that logs and exponential functions are inverses of each other. And then, so over here I have 2 to the 4th is equal to 16. And then I'm just going to keep going. So for number 17, I could write this as the log of 1/49 base 7 is equal to -2. So remember, the base is always the number we're raising to the power. And then for number 18, I would have the log of 1/144 base 12 equals -2. So the exponent is always on the equal sign part. And then for number 19, it would be the log of 225 base 15 is equal to 2. And I can always check it by going from the, oops, sorry, I was trying to shade that. That's funny. I can always check it by starting with here and making sure it makes that circle. So that would be like 15 squared equals 225, which is what I started with. Okay, that's a little recap of what we learned, part of what we learned yesterday. Are there any questions on that part before we move into the next part? And I appreciate that some of you were typing that into the chat, so thank you for sharing. Are we good? Can we go to the next slide? Okay, so if you weren't here yesterday, you're going to totally want to watch the video from yesterday. And I guys are busy. You might not have been able to, but you might be very confused without it. Okay, so today we're going to talk about the change of base theorem. Back when I was in high school, the change of base theorem was where it was at. Then they made all these advanced calculators that can do this without change of base. So it really depends on what type of calculator you have. If you have the old school calculator like I did, or a scientific calculator, even like Desmos, you're going to have to use the change of base formula. It basically says that if we have the log of x base a, we can actually write it as the log of x over the log of a, as long as the bases are the same. The reason why this is useful is because all basic calculators should have log base 10 in the calculator, which allows us to solve things that look like this. So like back before this section, how would you figure out what 5 raised to what power equals 10? Well, I know it can't be 1 because 5 to the first power is 5 and 5 squared is 25. So like I know that it has to be in between 1 and 2. But a log actually allows us to find that exponent perfectly. It's really cool. So I could write this as the log of 10 base 5 is equal to x. And then some of you will have a calculator. You might have a special calculator. I'm going to put special. If you have a special calculator, you can just type that in, just like that. If you don't have a special calculator, we can do what we call the change of base, and we can write this as the log of 10 over the log of 5. And that's going to give me my approximate answer. And so I'm going to show you what that looks like in Desmos. So give me a moment. I'm going to come back to the screen in just a second. But I'm about to go to Desmos, and I'm going to type this in. I'm going to do the log of 10 over the log of 5. Some of you will be able to just type this in. So you'll have to look at your calculator because I don't know which calculator you have. For our calculator for Desmos Scientific, I got approximately 1.43067. And that just simply means that 5 raised to that power is going to give me approximately 10. Some of you may have the advanced calculator that allows you to just type it in as the log of 10 base 5. Okay. So I'm going to show you, what's cool is I'm going to show you what that looks like in the calculator on the next slide. It's kind of fun because you can see what your calculator would look like if you had the opposite version, okay? I don't know if that makes sense, but I'll answer your question if you have a question. Okay, see what that looks like. So it says use the change of base theorem to find an approximation to 4 decimal places of each log. So if I'm trying to find the log of 17 base 5 and I'm using an old school, not even an old school, even Desmos. If I'm using a Desmos calculator or an old school scientific calculator, I will have to write it as the log of 17 over the log of 5. And this is what I'll get. And so you might want to practice that in your own calculator. However, if I have an advanced calculator, which some of you may have an advanced calculator, it actually allows you to put the little base in as a 5. And so I hope you're seeing the difference. And then like for this one, same thing. I would have the log of 0.1 over the log of 2. I get negative 3.321. And then down here, if you have an advanced calculator, you're going to get the same result, but you're just able to type the log in as it is. Are there any questions about the calculator? How many of you have this type of calculator? Does anybody have one that does this? Okay, you do? Okay, so Michael does. And then how many of you have to do this? Yeah, I do. My Desmos isn't as fancy as your calculator, Michael. I'm just kidding. Except for that it's true. Okay, but that's okay. We're all good. We can all use that. Yeah. Well, that's awesome. It's good that it does that. It's going to save you a little bit of time, right? That's nice. All right. Yeah. That's cool, Michael. Okay, let's try a few. Okay, so now I'm going to put it on you. I know Michael's got a good calculator that's going to help him, But how do you do it? And do you understand how to do it? Because the first key, the first step, when it looks like this, is going to be to convert it to a log, which is honestly what we did on our warm-up, right? So you can see why this comes into play and why we did that on our warm-up. We have to be able to convert it to a log. So when I convert this to a log, which is going to help me to solve for that unknown exponent, I'm going to write this as the log of 7 base 3 equals x. Now from here, if I have advanced calculator like Michael, I would just type it in. But for Desmos, and for most of you, I would use the change of base formula, which is the log of 7 over the log of 3. In either way, we're going to want to get the same answer. So I want to give you a moment to try it, and please type your answer into the chat. Make sure we're all on the same page. Caitlin, do you have the advanced calculator too? Yeah, because don't you have the same one as Michael? Okay, so Casio, and Michael, is yours Casio too? Yeah, look at that.
Yeah, it's a Casio.
Nice. You know, I'm gonna get one of those. That's pretty cool. I wonder if we have them at the school. I don't even know what calculators we have at the school. I know we have some that students can check out, but it's just hard when you guys are already remote and like some of you don't live in San Antonio. So, okay. All right, good job, guys. So we've got 1.77124, and I mean you can go as far as you want. I would just pay attention on like your assignments and stuff because it'll tell you like how far to go usually. And then over here, this would be the log of 13 base 5, or I could do the log of 13 over the log of 5. I bet when you came into this class this evening, you weren't thinking about how amazing it is that now you can find unknown exponents when you weren't able to do that in the past. You were probably like, oh my gosh, it's so cool. In the old math textbooks, they had all these pages of log tables, and you would have to use like this crazy table to do this. So calculators make it a lot better, right? And this is what I got for this one. It looks like you guys already helped me in the chat, so thanks. Awesome. All right. We're going to move on because that's all calculator. Now we're moving into the algebraic stuff. Yeah, with a little bit of calculator. Is it okay for me to go? You guys are good? Okay, cool. All right, so let's move into what we call the one-to-one property. It says, if x is greater than 0, y is greater than 0, a is greater than 0, and a doesn't equal 1, I feel like that should be the emoji that's like laughing out loud because that's just too funny. I mean, really, all these disclaimers. But I promise, we have to give you problems you can do. So you don't have to be like too worried about all of that. Then the following holds. X equals y is equivalent to the log of x equals the log of y. As long as, of course, the bases have to be the same, right? So that means that when this happens, it makes it easy to solve. Now it makes, just because of the way it's a log, people think it's difficult, but it's not. So if I had like the log of, what did I put? X base 3 equals the log of 15 base 3, and I asked you to solve for x, it would be really basic because you have a one-to-one property. X would just be 15. So what we have to do sometimes is we have to use properties of logs to convert our several pieces of logs to one log so that we can have one-to-one, and then we can solve. So we'll be doing that shortly. We are going to talk about solving logs, though, whenever it's not one-to-one. And then we'll have some other advanced type of problems. This is like really getting into the high-level stuff. Okay, so please give me a thumbs up when you guys are ready to go. Okay, are we good? I think we're good. I saw enough. All right. So let's talk about solving logs. And in this score, so I like to think about soccer. I just can't help it. I really like soccer, right? And I'm going to draw a terrible picture of a soccer ball. It's not great. That's okay though. Anyways, I like to think about the score in soccer when I think about logs. And actually, it always helped me to think this way, even whenever I was in college. So for letter A, I have 7 natural log of x equals 28. That would be a score of 1 to 0 because I have 1 log on the left and I have 0 on the right. And then for letter B, this would also be a score of 1 to 0. So I can't use the 1-to-1 property because it's not 1 to 1. It's like 1 to 0. When you have a score of 1 to 0, what you have to do, your first step will be to isolate the log, of course, but after you isolate the log, you will have to write it as an exponent. You'll have to do that. Okay, so on letter A, I have 7 times the natural log is equal to 28. And I want to get the natural log by itself. So I'm going to divide 7 first. And then I have the natural log of x is equal to 4. Now over here, it already is isolated. I don't have anything in front of the log. And this part is in parentheses, so it is bounded by the log. So for both of these at this step, I would need to write it as an exponent. Now, if you remember from yesterday, that's the natural log. The natural log has a base of what? What is the natural log base? Yes, good. Okay, it's e. Now, they're never going to write it for you because they're rude. No, it's not that they're rude. They're just not going to write it. It's assumed. E is right there. It's in green. It's actually invisible and it's not really there, but we're going to pretend it's there. So if I write this as an exponent, it's going to be e to the 4th is equal to x. And then depending on how they want your answer is how you would write it. This says give exact values. So my answer would just be e to the 4th. Because if I type e to the 4th in my calculator, I'm going to get a really long decimal that goes on forever. So if they ask you for exact values, you would just be done. If they tell you to round, that's when you would type it into your calculator. Okay, so that's letter A. Now let's talk about letter B. I am stuck. How do I solve this if it's 1 to 0? It's already isolated. Now I need to write it as an exponent, which is what we did during the warm-up, right? So I start with 2. I go across to 3. So 2 cubed equals all of that. So that is x cubed minus 19. Once I write it as an exponent, then I can see, okay, how am I going to solve this? And so I can kind of work through it. I see that the 2 cubed would be 8. And then I'm just trying to get x by itself. So I'd probably go ahead and add 19 to both sides. And I get 27 is equal to x cubed. And then I will take the cube root of both sides. And I get x equals 3. However, in dealing with logs, there's this thing called extraneous solution. That means that we do everything right algebraically, but our solution is actually a domain restriction. So we always have to check our answers for logs. Now this one's going to be fine. When I plug 3 in, I just have to make sure that right here I don't end up with a negative. So I know that 3 cubed is 27 and 27 minus 19 is 8. And because it's not negative, we're good to go. But if I got something like, I don't know, like 1, and I plugged 1 in, and then I got 1 minus 19, then that would be a negative right there, and that would be a no-go. And your calculator will even tell you, if you do the log of a negative number, it's just like your calculator explodes or something. Well, actually, it just won't let you do it. It'll say something weird. I can't remember exactly what it says. All right, because we're going to get to some that are extraneous. Are you guys good? Can we go to the next one? We're going to up the level of craziness in about 5 seconds. Are you guys ready for a crazy one? We're gonna go crazy. Okay, so this next one is, I want you to think about what the score would be for this next one. So if I was thinking about how many logs do I have on one side of the equal sign versus the other, I wonder what that score would be. Oops. It would be 2 on the left and then 1 on the right. Okay, we've never had a 2 to 1. We just had a 1 to 0. We have a 2 to 1 score. Well, that represents a problem, right? What we want to do is we would rather the score be 1 to 1 because nobody likes to lose, right? So we're going to actually force this to become a single log. We're going to force that to become a single log. And we learned how to do that yesterday. Okay, I know this is a lot. Believe me, I would have spent like 2 days on what we did yesterday. It's crazy. We're going so fast. Okay, so I'm going to write it as a single log. Now, since that's a minus, that means division. And then I would have it like this. So I just took that 2 and I made it a 1 log. Now I'm happy because now my score is 1 to 1. And now that it's 1 to 1, I get to do some tricky stuff. Basically, I get to set the 2 parts equal to each other. Now from here, I'm going to finish solving it. Now this solving is a little tricky because we have x plus 6 divided by x plus 2, and we have an x over here. But if you guys remember from like elementary algebra or perhaps some of your other classes, I can write it as 2 fractions, and then I can do cross multiplication. So that's what I would do on this one. I'm going to do 2 fractions, and I'm going to do cross multiplication. I can put that x over 1. So I'm going to have x times x plus 2 is equal to 1 times x plus 6. And so these problems take a little bit of time. You can't have too many of these because they take a really long time. Now I'm going to distribute, and I'm going to get x squared plus 2x. And then over here, this is just x plus 6. But you can see it's turned into a quadratic. Since it's a quadratic, if you remember, when we solve a quadratic, we have to get everything to one side of the equal sign. So I want to go ahead and subtract over my x and my 6. And when I do that, I'm going to end up with x squared plus, so 2x minus x is just an x, and then minus 6. So the 6 had nothing to go with. So when I move that 6 over, it's just a negative 6. Then I have to, I can factor. So it's so funny because the reason why this section is last in this course is because you have to be able to do almost like 8 different things that we learned. It's like testing like 8 different objectives. I need to find 2 numbers that add to get 1 that multiply to get negative 6. And so I'm trying to find those 2 numbers. And eventually I would end up with, let's see, I think somebody probably typed it into the chat. Okay, negative 2 and 3. Thank you. That is correct. So I get positive 3 and negative 2. Now that works because if you multiply them, you're going to get the negative 6. And if you add them, you definitely get positive 1. Whew, but I'm not done, right? Because I have to set them equal to 0. So I set each of these equal to 0 because we are solving. And when I set them equal to 0, I end up with x equals negative 3 and x equals positive 2. All right, which is cool, except we have to check our answers. And when I say check, we're not checking all the way. We just have to make sure that we don't have any extraneous solutions. So one of the rules with logs is for the domain for a log, you cannot have a negative number. It's not allowed. So if I look at my original statement, which I'm going to write again right here. So if I look at my original, it only takes one place for it to be a negative, and then the whole thing falls apart. Okay, so if you think about this, let's start with 2. I'm going to take 2, and 2 plus 6 is 8. It's not negative, so we're good. I'm going to take 2 and plug it in here. 2 plus 2 is 4. We're not negative, so we're good. I plug 2 in here, and I get 2. It's not negative, so we're good. 2 is a valid solution. However, when I take negative 3 and plug it in, it would be okay here. Negative 3 plus 6 is positive 3. And it would actually, well, it's not going to be okay here, right? Because that'd be a negative 1. That one sucks. And then really bad here, right? And in fact, some of you may have noticed right away that negative 3 is going to stay a negative right there. When this happens, negative 3 is out. That is not a solution. The only solution is 2. Okay. We're going to have a few more. So I'm hoping that by the time we get through all of these, you'll start to understand that process a little bit better, right? But you can use your calculator as a guide, because if you type in the log of negative 3, it's gonna explode until you know. And then you'll know, oh no, it can't be that, because I tried to type it in and my calculator, exploded. Okay, so is it okay if we move on? Do you guys have any questions? I didn't make any mistakes? No, I'm just kidding. I'm going to try not to, though, although it's a good thing when it happens, because you guys always notice it. It's hilarious. So let's move on to this one. I need your help. I want you to look at this and type into the chat, what is the score? If you think of it as a score, what's that score? It is a 1 to 0. Okay, the reason why it's a 1 to 0 is because there is one log on this side, and there are 0 logs on the other side. So we're just comparing the word logs, really. Since it's 1 to 0, we're like a little sad, right? We can't use that 1-to-1 property, okay, because it's 1 to 0. Okay, so that's out. When it's 1 to 0, we're going to have to at some point write it as an exponent. We have to undo that log. It's the only way we're going to be able to solve it. And it's already isolated, because if you think about it, this is inside of the log. We can't really do anything to that until we undo the log itself. So when I write this as an exponent, I always start with the 2. I go all the way across. So 2 cubed equals all of that. And now we're doing another objective that we learned earlier on, which is to multiply this out, right? You can make a box if you want to, but we're using that distributive property. So you can see, as I've said, this is why we save this for last, because you can't actually do this without everything, almost everything that we've learned, all kind of put together. All right, so I multiply it out. That takes time in itself. It's really easy to make a mistake, so I need you double checking. I'm going to try to also look on my paper though. And then remember, we can combine right here. So I'm going to combine that, and I'm going to get 3x squared minus 19x plus 28 equals 8. We have another quadratic. Since it's a quadratic, we want to collect everything to one side. And the 8 is the only thing that's on the wrong side. So I can just quickly subtract 8 from both sides. That's like not a big deal, right? I subtract 8 from both sides, and then I'll end up with 3x squared minus 19x plus 20 equals 0. Well, this can be solved by factoring, but it's the advanced type of factoring. So there's another objective. It's crazy. These are crazy problems, right? So when I have a number here, remember, I'm going to multiply the 3 by the 20, and that's going to help me with my product. So my product is 60, and my sum is negative 17. So I'm looking for two numbers that add to get negative 19 and that multiply to get positive 60. So I'll give you a moment to think about what are those two numbers. And I'm going to start listing factors of 60 because that's really what you can do if you're stuck. And I think, yeah, a few of you have started to type it in. Okay, so negative 4 and 15, thank you guys for helping, is definitely going to work. So I'm going to have negative 4 and negative 15. Hold on, I'm running out of space. Okay, and then remember, these are going to split that one, right? So I'm going to have my 3x squared stays the way it is, but I'm going to be replacing negative 19 with the two numbers I got. Well, I got negative 4x minus 15x, and then that plus 20 stays the same as well. And that is when I do my factor by grouping. So I'm going to group this together. They have an x in common, so 3x minus 4. Over here, 15 and 20 have a 5 in common. So I'm going to take out a 5, and what a big surprise. When I take out a 5, I get 3x minus 4. I love how that works. And then I factor out the 3x minus 4, and I'm left with x minus 5. Wow. That's crazy. Oh my gosh, I'm not even done. Okay, now I'm going to set it equal to 0. Okay, so I'm going to set it equal to 0. And when I do that, I'm going to end up with x equals 5. Over here, I would have to add 4 and divide by 3. And I get 4/3. Okay, now from here, I will check to make sure I don't have an extraneous solution. And when I check it, I'm really just making sure it doesn't end up a negative, right? So I just have to check. So I'm going to do 3 times 5 minus 7 times 5 minus 4. Okay, so I start with that one. So I get 3 times 5 is 15. 15 minus 7 is positive 8 times 1. Great. That answer is good. 5 is good. Now let me try 4/3. So I'm just plugging it in. I just want to make sure that when I do this whole part right here, that I cannot end up with a negative. I have to do that whole operation and make sure I don't have a negative. All right, so 3 times 4/3 minus 7. And then times 4/3 minus 4. Okay, so when I do this, I can see right here that this is going to be a 3 minus 7, which is negative 4, times, and then this right here is going to be, let's see, 4/3 minus 4 would be 12/3, negative 8/3. However, the negative times the negative is positive, and so that means that this one also works. So we got two negatives, and you know what? This is negative 3. My bad. Yeah, 4 minus 7 is negative 3, not negative 4. My bad. Okay, so when I multiply that together, I actually end up with positive 8, sorry, it becomes positive. So because two negatives make a positive, 4/3 is also correct. But look, you don't have to do all that by hand. It's kind of exhausting, honestly. I mean, look at what I just did. You can use your calculator as your guide. If you type in log and then you type all that other stuff in, you just need to do a quick check to see if it ends up being negative or not. So you can use your calculator to kind of test that as well. All right, so we're doing some fun, difficult problems. Are you guys ready to move on to another one? This one's actually a little less stressful. But I can always go back too. Like if you want to stay on, I can explain things to you. Okay, is it okay for me to go to the next one? Or did you guys need me to wait a minute? You guys are okay. All right, cool. All right, so here we go. We've got another score of 1 to 0. I want to give you a chance to try it. And feel free to send me a direct message, or you can do that too. But if you want to show a little bit of your steps, that would help. Like if you want to write it, so write it as an exponent, and then I'm going to ask you to type that into the chat. Multiply it out. Type that into the chat. If you want to show some of your steps, that would actually really be helpful. Okay, I'm going to give you guys about 3 to 5 minutes to try this problem, and of course we'll go over it together. Okay, I'm going to start to show my work because I can see that you guys are moving based on the chat and the direct message that you guys are sending me. Okay, so I write it as an exponent, which would be 3 squared equals x plus 5 times x minus 3. I multiply that out, which I can see that most of you did correctly, actually. Yeah. So we got x squared plus 2x minus 15 equals 9. Good. And then it looks like you guys subtracted. Some of you got that far. So you subtracted 9 from both sides. You're doing a really good job of showing your work. And then I have x squared plus 2x minus 24, which is correct. So we're about like halfway done, right? So it's a lot of work. I know these are a lot of work. You don't have too many of these because they just take forever. And then I'm looking for two numbers that add to get 2, that multiply to get negative 24, which you guys have also showed me is x plus 6 and x minus 4. I set those equal to 0, and I end up with negative 6 and positive 4. Okay, then I have to see which ones work. Sometimes they both work, sometimes only one of them works. You just have to look at the problem itself. Okay, so I'm going to start with 4, because 4 is the easier one. When I plug 4 in, 4 minus 3 is 1, and 4 plus 5 is 9. So yes, 4 is good. I did not get a negative result, right? When I plug negative 6 in, I have negative 6 plus 5. Let me erase this so I have a little more room to show you what actually happens. There we go. Okay, so when I do negative 6 plus 5, I get negative 1. But I'm going to times it by the other result that I get. So when I do negative 6 minus 3, I get negative 9. However, this answer is only okay because when I multiply negative 1 times negative 9, I get positive 9. Since I get a positive, this whole result is what I'm having to look at because that's what's inside of the log. Since I get a positive 9, this one also checks out. So in this case, both answers work. Crazy. I know, it is crazy. Okay, are there any questions on that one? And like I said, feel free to stay on. I can go back, and if you have a certain what did you do in this step, I can totally go back and show you if needed. All right. Thumbs up. Can we move to another one? There's just so many different types. I'm trying to cover as many as I can. Okay, so now we have another one. Please type what you think the score is into the chat. So what do you think the score is for this one? So I'll give you a moment to type it in. Oh, you guys are fast. You guys are too fast. Okay, 2-1. I thought that would take more time. Okay, yes, it's 2-1. So we have 2 and we have 1, so 2-1. If the score is 2-1, we must force, and I know you can't go back in time in soccer and force it to be 1-1, but we have to force it to be 1-1, which means we're going to have to take the 2 and make it a 1. To do that, we have to rewrite as a single log, which we also did yesterday, but it's not that bad. If there's a minus here, it just means division. If it was a plus, it would mean multiplication. So I have x minus 10 over x minus 6. Now it's 1-1. So now we're happy because it is 1-1. Now I can just write it as x minus 10 over x minus 6 equals 2. But since I have a fraction on the left side of the equal sign, typically what we tend to do is just to make another fraction on the right side by putting it over 1, and then we can just cross multiply it. That will usually work for us, and it's a little easier to understand. So then I'm going to have 2 times x minus 6 is equal to 1 times x minus 10. Of course, 1 times x minus 10 we know is just x minus 10. And then I have 2x minus 12. It's not a quadratic this time. You guys must be so happy. I'm just kidding. I know you love to factor. So it's not a quadratic. It's just a linear equation. So I just have to get my x's on one side and then my numbers on the other. So I'm going to subtract x from both sides, and I end up with x minus 12 equals negative 10. So then I add 12 to both sides, and I end up with x equals 2. And I feel pretty good about that answer. I mean, I did all that work, but I want to make sure it works, right? So I have to check to see if it's extraneous. So it's not that we did the algebra wrong, but if I plug it back in, am I going to get a negative, right? Okay, so I did all that work. Now let's see if it pays off. I go up to the top. I put a 2 here. 2 minus 10 is negative 8. Well, that sucks because these are separated logs, so it only takes one log to ruin it for everyone else. In fact, this next log would also ruin it as well, right? So at any point, anytime I get a negative in this part of my log, it's not going to happen. So that means after all that work, our answer is actually no solution. And I just want to point out that sometimes MyLabs, actually does a symbol. But it was still worth it because we got the answer. It's just the answer happens to be no solution or no answer. Sometimes that happens. Are there any questions on that one? Okay, we're going to talk about one more, and then I'm going to talk a little bit more about like final exam and all that stuff. Okay, so is it okay for me to click? You guys are good? All right. Okay, so it says solve the exponential equation, express the rational solutions as decimal to the nearest thousandth, which would be 4 decimal places. Okay, so this one, I chose this one because it looks a little different than the ones we've been doing this evening. But it does require some work. So I want to give you a few minutes to at least try to get started on it, and then we'll talk about all the steps. Okay, so the first thing I want to do is I want to make sure to isolate the base, which of course has the exponent in it, right? So I'm going to try to get this piece completely by itself, right? And I've got some things in my way of doing that. The first thing I have in my way is that positive 2, right? Because it's 3 times that plus 2 equals 101. So I want to get that that 2 raised to the power by itself. So I'm going to go ahead and subtract 2 from both sides. That would be like my very first step here. Okay, then it looks like that. So it looks a little better. Like I can tell I'm a little bit closer. And then I need to get rid of the 3. So to get rid of the 3, I can just divide both sides by 3, because this is just 3 times this, right? So I'm going to divide both sides by 3. And then whenever I divide it by 3, I end up with 33. And now it looks like this. Okay, now once I get to this point, we are going to have to use our calculator, and we're going to have to use the change of base. Because what's happening is 2 raised to what power minus 1 equals 33? I don't know. I know that 2 to the 5th power is 32, right? I know that 2 to the 5th power is 32. And I know that 2 to the 6th power is 64. So I have a good idea of like where this answer would lie, but I can't just find it in my head. I'm going to have to use a calculator. That's where the change of base in our calculator really comes in handy. So depending on which calculator you have, I would write it as a log first. So we're going to write it as a log. We did that on the warm-up. Remember, it's just the log of 33 base 2, and then the exponent always goes on the other side of the equal sign. Now from here, this is where your calculator comes into play. You're going to have to use a calculator here. You have to. If you have Caitlin and Michael's type of calculator, you just type it in. If you have Desmos, which is what I would have to do the log of 33 over the log of 2. And I'm going to do that, and then I'm going to show you how to finish the problem. Okay, so give me a second. Let me add 1 to both sides. So I use this. I got my calculator. I got the 5.0, whatever. And then I need to add 1 to both sides. And I get 6.044. Says the nearest thousandth. Tens, hundreds. Okay, yeah, 3 decimal places. We're good. So that would be my answer. And then what's really cool is if you wanted to super check it, you could do, in the original, you would just type in what you got and make sure you get 101. Now, it wouldn't be perfect because we rounded, but it would be approximately 101. You'd probably get like 100 points something something. It would be very close. Okay, are there any questions on that one? So what I'm going to do in just a moment is I'm going to show you, I'm going to talk about your final a little bit. I'm going to show you some more things on Canvas. And then, of course, you can stay on if you need to, if you have any questions. Okay, guys, good? Can we go? Next slide. Okay.